Hello, my dear boys. All of you are welcome to my online class. Hope all of you are well by the grace of our Almighty. Okay, and now today I will discuss on also chapter 7. The name of our chapter is Waves and Sound, and today's topic is we will try to solve a creative question. Okay, so our class is on how to solve creative questions. So let's the creative question first. So our creative question is wave takes 0.2 second to raise from A to B. Here this is our figure, and here the wave needs to travel A to C is 0.2 second. Clear? Here you can see the direction of propagation of the wave. Here the direction is left to right. Okay, now we need to now our question is question number A is what is timber, and question number B is how does the velocity of sound vary, explain briefly. And question number C is determine the velocity of the wave. Okay, and question number D is keeping the amplitude same if wavelength is half, then what will be the change in wave speed? Show mathematically. This is our full creative question. Okay, now we will try to solve all this part of this question, or we will discuss how to solve all this part of the question. Okay, now we will firstly we will see what is the answer of question number A. Question number A is what is timber? So write what is timber. Answer of A. What is timber? The characteristics of sound by which we can differentiate the sound produced from different musical instrument is called timber, or quality of sound. Okay, so we see that timbre is a characteristics of the sound. What type of characteristics? The characteristics of sound by which we can differentiate the sound produced from different musical instrument is called timbre, or it is also called the quality of sound. Okay, this is the solution for question number A. This is our knowledge based question. Okay, then the answer for question number B. This question is called comprehension based question. Okay. Now our question is how does the velocity of sound vary? Explain. How does the velocity of sound vary? Explain. We know that the velocity of sound is varies in different way. Number first way, we know that the velocity of sound is square root of the temperature of the environment. Okay. So if temperature is increased, then velocity also increase, and temperature is decreased, then the velocity is also decreased. And the velocity of sound is also we know that the velocity of sound is also inversely proportional to the square root of the density of medium. Okay, if the density of medium is increased, then the velocity decrease, and the density of medium is decreased, then the velocity increase. Okay, now that number third number is elasticity. Elasticity. If the elasticity is higher, then the sound velocity of sound will be maximum. Such as the velocity of sound is 5 times greater than the velocity of water, and 7 times more than 7 times greater than the velocity of steel is greater than 7 times greater than the velocity of air. Okay, so we can say that if the elasticity is increased, then the velocity of sound is also increased. So our velocity of sound is varies in these 3 ways. Okay, so this is our answer for B. Now question number C. Question number C. The question number C says that determine the frequency of the waves. So here we have given that the time we see from the figure that to reach from A to C we need a time of 0.2 seconds. So A to C is our distance, and the distance is given and that is 10 meter, and our time is 0.2 second. So from this data we can determine the velocity of sound, velocity of wave. Okay, so velocity of wave here, and the distance from A to C is equal to 20 meter, and time needed to it covers the distance is two seconds. So from this data we can determine the velocity of sound. So we know that velocity v equal to is by t. So we can write 20 by 0.2 we are given 10 meter. Okay, so 10 equal to so we can write 50 meter per second. Okay, okay. Then from figure here I can I need to the figure. C. This is A, this is B, and this is point C. So here this distance is called a wavelength. So this distance is half of wavelength, half of wavelength, half of lambda. So to travel A to C, it cover the 5 times half of lambda. Okay, this is 1/2 of lambda, 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 and this is also 1/2 of lambda. So 5/2 of lambda is 2.5 lambda. Okay, so we can write, and the 2 here, the distance given from A to C is 10 meter. So we can write 5 into half of lambda equal to 10. Okay, or 2.5 lambda equal to 10. Okay, then we can write lambda equal to 10 by 2.5. So our wavelength is 4 meter. So according to this data, we already have our velocity v equal to 50 meter per second, and our wavelength lambda equal to 4 meter. So by using this data, easily we can determine our frequency. We know v equal to f lambda. So frequency f equal to v by lambda. So 50 by 4 equal to 12.5 hertz. So according to our given stream, we get our frequency is 12.5 hertz. Okay, so therefore the frequency of the wave is 12.5 hertz. Okay. This is our answer for question number C. Then we are going to solve the question number D. Okay. So then question number D says that if the amplitude is same, and wavelength becomes half. So our wavelength given that wavelength lambda 1 equal to we get lambda 1 as lambda 2 equal to half of lambda 1. Okay, and we need to the velocity v2 equal to what? So we know that v1 equal to f lambda 1 if the frequency is fixed. So we can here the frequency is fixed because the medium is same. Okay, because medium is same, we can say that the frequency is same. So v1 equal to f lambda 1 and v2 equal to f lambda 2. From these two equations, we can write V1 by V2 equal to lambda 1 by lambda 2. So V2 by V1 equal to lambda 2 by lambda 1. Or V2 equal to lambda 2 by lambda 1 into V1. Putting the value of lambda and V, lambda 2 is half of lambda 1 and lambda 1 into V1. V1 we get from the question number C is 50. Okay, then by calculating this we get 25 meter per second. So we can say that if the amplitude is same and the wavelength become half, then our velocity of the wave will decreased and the new velocity is half of the old velocity. Our old velocity was 50 meter per second, and so we get our new velocity is 25 meter per second. Okay, so this is our creative question. How to solve a creative question? Try to do this type of to solution this type of creative question at home, and if you face any problem, don't hesitate to contact with me. Okay, so in our next class we will also discuss another creative question from this chapter. So until then, goodbye.